So yeah, in brief, that was that. Let's come back to calculus. There is a question later I did that combines everything, but here I said let's bring in calculus also so that we can get time on this one. It says you are given this determine dy over dx there, and with calculus I think the concepts already you know, but what I wanted to bring to your attention is calculus is more dependent on your exponents more than anything. So like this question here, 4 marks, when I'm working on this question, I think also you can check it on your side to say I cannot do calculus on 1 over x, and I cannot do dy over dx on that square root of x, meaning I need to first simplify them using the laws of exponents so that I can apply the rules of calculus. So y then becomes, remember 1 over x is what?
Negative, it's x and negative 1.
Remember that part to say, always remember that one. And then plus, what about square root of x?
Square root of x, it's 2x to the half.
X to the half. See, now let's apply our calculus. What is dy over dx?
dy over dx, I don't remember this one, but I remember that it goes down.
So what you do this, take your minus. Okay, let me give you the general formula. If I've given y is equal to a x to the power of n, so if I say dy over dx, you have the formula. Check your formulas again. Go to your formulas, because this formula is there.
I hate technology sometimes.
Just under calculus, I think they'll write calculus there. Oh,
So-called parabola differentiation.
yes, that one.
Yeah, it's here, n minus 1.
Yes. So what they do, look at this. It's anx n minus 1. Am I right?
Yeah, they use n, but
Yeah.
it's pretty much the same.
So they do this. They take this n, you bring it here to multiply. So it will be n times a. It's a n and then x. Then you say n subtract 1.
Right, so you bring that down.
So you are bringing it down and then you're subtracting 1. So bringing down, subtracting 1. Bringing down, subtracting 1. So even here, when we've got this part here that I have of negative 1. So what do? I bring it down. It will become what?
So, okay, sorry, I just got that too. Okay. So, at this point, we'll get a negative x, then we'll have a negative 1. Minus 1.
Minus 1. You see that? That is that.
Right.
And then let's continue with the next one. What about 2? What do I do with the 2? So it is plus. You write the 2. What am I dropping now? You are dropping what?
The 1.
You are dropping the half now.
Oh, the half. So we let the 2 go as it is.
Yes.
2. We go to the
it will be 1 over 2.
Half. And then x. Then 1 over 2 minus 1.
1 over 2 minus 1. That's it, man. Then from there you simplify. It's minus x to the power negative
minus 1
2.
minus 1. That should give us a negative 2.
Yes, and then you simplify that half there, which is plus
-2.
X to the power what?
Plus, 2 times a half, that's 1. So it'll be just x.
Yes.
Then a half minus 1. A half minus 1.
It's negative half.
Yeah, it should be negative half.
Now, most of the questions you'll find, they will tell you leave your answers with positive exponents and insert form. Positive exponents. So, but this is fine. They never said anything. But if they say leave your answer with positive exponents, meaning you need to simplify further. You see, I've got x minus 2. So to back again to exponents, it will be 1
so it will
minus
be
1 over yes,
x squared.
Yes.
Plus
1 over again.
1 over. So if it's negative like this, it's going to be 1 over, and then this will be root 2.
Thank you, because it will be x to the power of half. Now, that x to the power of half is simple. When you simplify it as square root of what? Of x. Are you with me? So this then becomes number 1, positive exponents, and in sets. These are sets. Are you with me?
I'm listening.
Alright, now let's look at the next one. There it is. How many marks? 4 marks. Determine dy over dx, or f of x here. But since they gave f, so you say f prime x. I think that.
Sorry, just give me a few minutes.
All right,
dy
so
over dx.
now,
I copy the question.
okay. If f of x is equal to
x to the power 4 minus
okay.
3x squared. Okay,
Yes.
let's get to this. So it's practically just redoing the same thing. So they've just complicated it unnecessarily. So the question here is that do you open these brackets or do you leave it as is with
so
them?
this is the thing. Now when you're dealing with calculus, man, every time never do calculus when things are not simplified. For example, you see I've got this square root. You see this square root? It's a problem. I need to first of all express it as this is equal to x to the power 1 over 2. Are you with me? And then I close there, it will be x to the power 4. Now I have a problem with that fraction because you cannot differentiate a fraction.
So it will be minus 1.
Minus 1, but leave the 3. 3 is just a number. Leave that 3.
So I can leave the 3 and then
yes.
Okay.
And then that's how you write it
x
now.
To the minus
you write
2.
it outside, x to the power negative 2. You see how I've done that?
Okay. Yeah.
But again now, Sabelo, you cannot differentiate when things are still multiplying like this. You can't apply the rules. So you now at the end of the day, you find students applying rules to say I'm dropping these, but you cannot because things are not yet simplified. You can only do when it's single items. So here I have to open this bracket and open that bracket. Are you with me?
Okay.
So let's continue. So that's the part. Always simplify to the last and then be left with single exponents, then apply the rules. So what do we do there? It will be x to the power, remember this is multiplying. It's 1 over 2 exponents plus 4. You agree with me?
Yeah.
Minus what? 1 over 3 again. X to the power negative 2 plus half. You agree with me? Because it's multiplying. And I'm using the first law of exponents. Are you with me?
I'm with you.
Then let's continue now. What does it simplify to become here?
So what do we have? We've got
half plus 4.
To the positive half plus 4.
Add for me half plus 4 is what?
4.5.
It's 4.5, which is 9 over 2. Am I right?
9 over 2, yeah.
So let's leave it as like that. 9 over 2 minus 1 over 3. What about this one? Negative half plus
1
half.
1 over 3. Is it a negative half plus half?
Yes. Negative 2. Sorry, negative 2 plus half. Sorry about that. Negative 2.
Negative 2 plus half will be negative 1.5. So it will be what?
Negative 3 over 2. You see this? Now, this is still your f of x, my man. So at this stage, then can you apply the rules? Now, there is the temptation.
At this stage, you've only worked for 1 mark.
Yeah, you have worked. Actually, you're not really 1 mark. If it's 4 marks, they'll give you 2 marks for this. They will give you 2 marks.
Yeah, mathematics.
I understand. Now, look, man, I need to emphasize this to you. When you apply the rules of calculus, don't apply them to say, in one expression, you are still opening the bracket, but in another one, you are doing the rules of calculus. They will penalize your marks. When you apply the rules once for every item that you have. Are you with me? So always be careful. You cannot, for example, apply the rules here and then maybe go there and finalize your addition or subtraction and everything. Are you with me? So the moment I come here on this one and say f, remember it's f prime x, that is my dy over dx, is equal to, once I wrote that prime, it means everything following must be under the rules of calculus. If you don't do that, then you'll be penalized because you are not following, you're not following the right procedure. You are doing some you're not doing, even if your answer is going to be correct in the next, but you're not going to get your full marks. So let's apply the rules now. Remember the 9, what does it do?
Yeah, the 9 over 2 goes down.
Becoming what?
Becoming 9 over 2x.
X.
9 over 2 subtract 1.
Thank you. Please apply this. That's where your marks are also. Don't do shortcut. Minus 1 over 3.
Minus 1 over 3.
I drop.
Yeah,
bracket.
1 over 3 and then in brackets negative 3 over 2.
Please do that. That's the way to go about it.
And then we still have an x here, no? Yeah, we do have an x.
X must always be there because that's what you're doing.
X, and then we've got negative 3 over 2 subtract 1.
You see, please, this is a mark. This statement is a mark. If you oversimplify now, you want to add and subtract mentally and you make errors, you lose your mark. So let's continue now, which is 9 over 2. Can you separate that for me?
9 over 2x.
What is 9 over 2 minus 1?
9 over 2 minus 1 is practically the same as 9 over 2 minus 2 over 2, so it will be 7 over 2.
7 over 2. So you've got x to the power 7 over
7
2.
over 2. 7 minus. And a third
multiply
times
that. This
2.
multiplies, cancels there.
Yeah, the 3 cancels the 3, so it's 1 over 1, so it's a
look at this one.
half.
Look at this one. I have a negative and I have a negative inside. You see that?
So it's going to add.
So it's going to be positive. You see that?
Yeah.
Yes, so positive 1 over 2.
It's going to be positive 1 over 2.
Minus 3 over 2 minus 1.
Minus 3 over 2 minus 1. And that's the same as 3 over 2 minus 2 over 2. So it's going to leave negative minus. No? So it's going to leave a minus 1 over 3. Let me just confirm.
Check,
that.
no? I think
I have a feeling that I'm doing nonsense here.
No,
so
that one
minus
must
3
minus 5 over 2.
Minus 1. Yeah. I could tell that something is wrong.
Yes, minus 5
minus
over 2.
5 over
okay,
2.
Yes, that one. You're right there. All right. So now they say this, but let's take this to positive exponents. What will you say?
Positive exponents, everything will remain the same, so it will be 9 over 2 times x.
Now sets, with positive exponents and sets also.
Oh, it's positive exponents and sets.
Yes,
so I need to get rid of the bloody noise. Alright, so we've got 9 over 2. My x, what's going on here? So it's square root, so it's basically the square root of x to the power 7.
Thank you. X to the power of 7. Yes. Plus
a half. And that's basically the square root. A negative half.
There's a negative there.
Okay, so I still got a square root sign. And I still got the x minus x positive 5 at the bottom. I've got 1 at the top. So I've got half times 1 over square root of 5.
So we've got to, let me write this, half times what? 1 over square root of x to the power?
X to the power 5.
Thank you. So when you write it, this is how you write it, it's 1 over. So in other ways, it's, remember 2 is already at the bottom. So it's 2 root x to the power 5. No, sorry about that. X to the power of 5. That's what you're saying there. So this is now the final answer. Alright. But if they didn't say do that, man, please leave your answer here. If they don't explain anything, just leave your answer there to avoid making even more errors in case you're not trusting yourself. But I don't see any problem you're having. I'm happy with your simplification further. You're not showing any challenges there, you know. So let's look at this one again. This was 6 marks. I don't know why they made it 6 marks. But now I repeat again. You cannot differentiate when things are still mixed up. Please. You can only differentiate when you've got single exponents. Now, look at this. Determine dy over dx of the following function by using the rules of differentiation. Leave the answer in with positive exponents and insert form where applicable. Look at this guy. Y is equal to that.
5 root x multiple divided by x. So looking at this guy, so this would be equal, let's see, that's gonna be x to the negative 7.
So what must have no, I know you wrote something right there, but say it right. You are saying x to the negative 7. We are mixing up things. What must I write? Not x to the negative 7. What are you saying?
On the first one.
Yeah.
So I wrote x to the power negative 7.
No. Remember, x is going alone. It's going up. It's x that is going up.
Oh,
so it can't be negative 7.
7 stays on its
7 is a number there.
On its own.
Yeah. Remember, it's 7 times 1 over x. See? 7 times 1 over x. You see what I just did there?
Negative,
So what do you write?
So 7 times x to the negative.
Thank you.
To the negative 1.
Thank you, sir. Thank you. 7 is still positive there. It's 7 times x to the power negative 1. Okay? Minus what?
Minus 5. Minus 5. And that will be x to the power of a half.
Thank you. And this thing is still divided by what?
And that's still divided by x. So at this point, let me see. The whole thing is dividing by x. So if I put brackets around it, if if I put brackets around it, that's basically multiplying by a negative x to the negative 1.
Thank you. That is another way. That actually this is more proper for me. You are telling me, or you should have seen that this is on its own, or this is on its own. If you didn't want to put brackets, I understand. But it's fine. Let's continue with your method. It's brilliant. I'm happy. Continue. What do I do from here?
Okay. Well, yeah.
It's you are expanding. You are opening the bracket.
We're expanding. I have to expand it.
So
now.
how does it go? This goes there. This
so
goes
it'll be 7. We'll have 7. Now x, since we're multiplying, will add that negative 1.
Negative
Plus
1.
minus, so it'll be minus 1. Then it'll be minus 5 x to the half minus 1.
Yes, because you are adding those. You are right.
Because we're adding those. So that's 7 x to the negative 2.
Negative 2 there.
Minus 5 x half minus 1. That should
negative
be
half.
that should be negative
half. So look now, man, at this stage you just have got your single x has got its own exponent. You see, you have simplified it until where you want it to be. You see, then you can apply calculus now.
So it's 7 multiplied by negative 2 x.
So you write dy over dx now.
Dy over dx.
Let's not forget, say all along, as you said, it's like, you know, before you fry your chicken, my man, what you need to do, you must clean it up. You know, it's dirty, my man. You clean up, you know the whole job of cleaning it up. So that's what you're doing here. You know, you're cleaning it up. So it becomes what? 7.
So 7 times negative 2.
Thank you. X.
And then x to the power negative 2 minus 1.
Thank you.
And then we've got minus 5 times negative half to the power x negative half minus 1.
See, then from there, I think that's why they were trying to make it 6 marks, because it needed just a lot of nothing there. Nothing is being done much, but it's just algebra, you know. 7 times negative 2
is negative 14 x to the negative 3 minus that's 5, negative 5 times negative half, so that's 5 over 2. So that's a positive 5 over 2, so that's plus 5 over 2. That's plus 5 over 2.
Yes, sir.
And then we've got x minus half. So that's what's negative 0.5
yes
minus 1 will give us 3 over 2.
Yes.
And I think that's it.
And then how do we then convert this into positive exponents? Remember?
Now, positive exponents we will have. We've got our negative 14 then. Then we've got that will be over x cubed.
So
plus
it's what? Negative 14 over
x cubed.
Thank you.
And then we've got plus 5 over 2 there. Then it's the square root of x cubed.
Thank you. You see, that is how this whole thing becomes. And just to be sensitive again here, look at this, man. The way you put your, let me just come back here. The way you put your cube, it mustn't look like now it's a 3, you know, it's like x and 3. Please make sure that your cube is still a cube, eh? You see my 3 here is more like, it's no longer an exponent. So just be sensitive. My exponent must still look like my exponent, you know. Just to, you know, some they write it like this now. So it's x3 now, you know. But it must still look like a cube, you know. But this, man, I don't know why you say your calculus was a bit shaky, but to me
my calculus is a bit shaky, but you know,
this is good. This is good, eh?
You remember things as time goes on.
This is good. Now look at this one. I think this was one of the other questions also I brought in here. It says determine the following function by using rules of differentiation. Leave the final answer with positive indices. Indices is still exponents and in set form where applicable. Talk to me on this one. What do you suggest?
Right.
Let me give you a chance to write it down.
This fan is just blowing out everything. So y is equal to 3 cube root 3 x squared.
So it's 3
Yeah.
cube root cube root of x squared. Yes.
5 over root
X.
x.
Yes.
So what do we have for ourselves here? We've got ourselves a 3 times x.
We have here a question. I like this question in the sense that it will give us that kind of gradient. You see, this theta is the one that we're trying to deal with. So it says, consider figure 1 below. A, B, C has vertices, so they gave us A, B, C there, which is fine. P is the midpoint of AB, which is also fine. Let the angle of inclination of AC be theta. I think you can see AC there being theta, and the angle of inclination of AB being beta there. Now the question comes, says, number 1, 4.1, determine the coordinates of P, the midpoint of AB. So you, as you did mention, you've got your formulas there. Let's quickly do this because we've been working on it.
So what is this coordinate of P?
The midpoint
of
yeah.
AD. I don't even think we
need
a formula for
so
this.
So it's x2 plus x1, that formula there.
X2 plus x1. Let's divide it by 2, and then that's plus y2 plus
y1. So x2 plus x1 over 2 and y2 plus y1 over 2. So let's do that.
Divided by 2. So which line are we working on? Midpoint AB. Midpoint AB. I just finished drawing this thing now.
Okay, midpoint AB. Which will be
midpoint AB. So I've got my x values will be 5 minus 5 plus 7 divided by 2.
Yes.
And then
the other one is, okay, let me bring it.
Got y 1 plus 5.
The other one is
divided by 2.
Okay, the other one is, it's negative 1 there. Just check it.
It's
a negative set.
And then I've got negative 1. I'm looking at my drawing and now
negative.
I was just rushing through it.
Okay, yes, negative 1
so
plus
negative
that
1
over
plus
that.
5. So we've got 5 plus 7, 10, 12 divided by 2, that will be 6.
Okay, that will be 6. I'm writing 5. 6, yes. And then
and then we've got
4
over 2. So
that's 2.
2.
So we got the midpoint there. So P, so which means our P there is 6.2. Okay, so far so good. Now the next one says
4.2.
The gradient of AB
line
and AC. Two gradients, AB and AC.
MAB, that is rise over run, so y2.
So we'll say M of AB.
Y1. It will be y2 minus
y1 over x2 minus x1. Remember, they don't give you this formula, hey? Y2
this is
minus y1.
That's how. That's why I remember it as rise over run.
Okay.
It's going up.
Rise over run. Okay, I see. I like that. All right. So what do we have now?
So my y2. So it's the midpoint of AB that I'm working on. I'll just start with y. I'll just take the negative 1.
Okay, negative 1. Subtract 5 over.
And that's over. And what do we have here? We've got 5 subtract 7.
And then what does it give you?
Minus 1 minus 5.
It's minus 6.
Minus 6.
Over
so
minus 2.
Minus 2.
Which is equal to?
Which is equal to practically a 3.
3. Right. So here we've got M of AB is equal to 3. And it makes sense, man. Look at the line. It's a positive gradient, you see? So it must make sense. Now, let's look at this M of, they said M of gradient of AB and AC. Let's do AC now. Gradient of AC.
So, again, this time I'm not going to bother writing down the formula. We'll just go straight into
this one.
Minus 1.
Okay.
Minus 5.
So, minus 1 minus 5, okay. Over
9 minus 7.
9 minus 7, all right.
Minus 1 minus 5 will give us another negative 6.
Negative 6 over
9 minus 7 will give us 2.
Over
which
2,
is equal to
which is equal
negative
to
3.
Negative 3. So we come here and say the gradient of this guy here, M of AC, is negative 3, all right. Okay?
Yeah.
Happy? So that is fine. Okay, now.
Having also that 4 marks, building marks.
Yeah, this is good. The only thing here is to avoid errors. They want to trick you on errors there. Look at this, the size of BAC.
The size of triangle BAC, so it's the angle on A.
I'm angering them for just such small marks, but it's fine, man. So the angle of size BAC. So what do you do then if they want to find the angle of size BAC?
So from this point, without turning my page back, if I have to find the angle of BAC, kind of what we're doing the first time. We can use that inclination angle.
That's where we are. You are looking at the angle. So you've got this gradient. So here what you simply do is to say to me arc10, beta. Let's start with beta.
Tan negative 1 m.
Yes.
Okay.
Tan negative 1. So the first one is tan. Let's start with beta. Tan negative 1 3. The positive one. Beta.
Okay.
What are you getting?
So it's so which one are we starting with? We're starting with the positive.
Yeah, the positive, the 3. Yes.
So that's beta. It's not beta. I have the wrong one. Actually, I haven't put angles on the shape, but it's fine.
So shift 10 3.
10 3. That will give me a 71.565.
71.565. So that's what I'm gonna write here. 71.565. Find me now theta, which is now
negative 3.
Now be careful now. Remember what I said?
It gives us that, so this point, so what's the sign is this? Theta is equal to 10, that's negative 1. So it gives us that negative 71.565.
Yeah, now remember, Sabelo?
And then plus 180.
Thank you. You just say plus 180. Now you got it, yes. So what do you have?
Then it's 108.
It's 108. So what you do is you get your reference angle and separate from 180. So in a way you are going to say theta is more like 180 plus arc10 plus arc10 negative 3. That's what you say, which is 108 comma what?
108,435.
435.
5, yeah.
Okay. 435. So this is this angle 108. Yeah, we are working in circles though, comma 435. But now we can find this one now.
Yeah, now we can find that one, which is just 108 minus
71 comma
71 0.565. Then it's 36.870.
36.870. So this is 36.870. But are you also seeing this, Isabella, that even this angle here was 71.565?
Yeah, the gradient,
because it's the other way around on a straight line. Angles in a straight line now, you see, in a way. So, but whatever you do, man, it's still fine. I'm looking at it. Don't worry, I know you say, but this is working in circles. Look, you just got your answer. What is important is get the answer. Let's follow this way, because some questions are not as simple like that. So if you can have a way to say, okay, when I'm getting this, until you start seeing answers now, but start like that, get your reference angle, say plus 180. It will always make you not to forget that I cannot have a negative answer. You know what I mean? All right. So next one says, the equation, determine the equation of the line that passes through point A. So there is our point A, which is perpendicular to AC. There is AC perpendicular to AC. Leave the answer in gradient intercept form. So,
okay. So
what? Let's repeat again.
The answer in gradient intercept form.
Right.
So what's gradient? Is that y equals to m?
Yes.
Mx
plus
c.
That's y is equal to mx plus c. That's the gradient intercept, because this is your intercept and m is your gradient. All right. So now.
So if it's perpendicular to AC.
There is a point A which is perpendicular to AC, meaning.
If it's perpendicular to AC, then it means that AC's gradient is negative 3. So that times, let me see, just grab my calculator. So then the gradient m1 times m2 must be equal to, the gradient will be 1/3.
It's 1/3. So what you must do, like now, let's do the working, because it's important there. So you say m1 times n2 is -1, then you say -3 times M1, we want the perpendicular, then say m perpendicular is equal to -1, then divide by
-3 times.
Yes, please don't forget such working is still important.
Yeah.
M perpendicular is 1 over 3. Am I right? You are right there.
It's negative 1. Yeah.
So now what do we do? How do we find the final equation now?
It's 1 over 3. So it's 1 over 3. So final equation. So it's y is equal to mx plus
Thank
c.
you. Y is called mx plus. I prefer this version. Some they use that one. Y minus y1 is equal to m, still the same, x minus x1. You have that in your formulas. But let's use this one first. So
that one, I mainly use that one because this time you don't have to go through so much trouble to
get your C.
To find the answer. Yeah, to find your C.
No, yeah. So let's do that one. I prefer actually whatever way I prefer that one.
Wait, but now, so C can be, because now...
Let's read the statement again.
I need the intercept?
Let's read the equation. It says the equation of the line that passes through point A, you see?
Point A.
Yeah, so we go back to that point A. We need that point A for that equation to say our A is what? 7, 5.
7, 5.
Okay, so you put it...
So if it passes, that will become our Y, so that will be our C.
Yeah, so what you do now, what you do is like here, remember this is X, this is Y. So you come to the Y is called mx plus C, where there is Y, you say 5 is equal to M, you just got it 1 over 3. X is what? 7.
X is equal to
then
7.
Plus C, then you calculate C. I think that.
Yeah, I understand.
So
that.
then it...
But won't C, most of the time won't C be... Also, this time what you'll do... Okay, I see how you'll do it. I see how...
I think that.
So you'll get your C using algebra.
Yes, you get your C using algebra. So now you take this other side, it will be minus 7 over 3.
Y is 5.
You need that point to find C. You need that point because it will give you your X and your Y values and your gradient to get the value of C, you know.
7 and then plus C. So what do we have here? We have C is equal to 5.
5 minus 7 over 3.
And that is equal to 5. Subtract 7 divided by 3. And that is equal to 8 over 3.
8 over 3. Then that's the answer now. As you say, to me, it doesn't need much working. Then I write the answer as Y is equal to M is 1 over 3. X plus 8 over 3. See? That was much quicker for me. But some, as I said, they come here, they apply it from here. Whereby now it will be Y minus, now their Y1 is the 5. You see that? Is equal to what? If you are using that equation, is equal to M, which is 1 over 3. And then X minus X1 is 7. Sometimes you can still use this one. It will still get you to the final answer down there. Are you fine? Are you fine on that?
Yeah, I'm agreeing with you there. I guess here it's about which one you see
yes,
first.
or you prefer, you know. Me, I feel like sometimes students make errors here when they expand. They start making some errors on algebra. This one of C is simple and straightforward, but it's just a matter of, are you careful with your expansion? It's still a good formula. Actually, your formula, when you go to your memos, they will prefer this formula for Y minus Y1, you know. But I always stick to Y is mx plus C. To me, it's the standard version, you know. Okay, let's come to this one. And then it says, show the triangle ABC is an isosceles triangle.
4.5.
Show the triangle ABC is an isosceles triangle.
So, okay, let me see. So, isosceles triangle, it's either you prove it by angles or you prove it by length.
Yeah, that's the wrong thing they did there. Already angles is clear, man. We said this, remember we just proved it by angle. You said this one, because if this is B, we agree that this B is 7 to 1. 565, right? And also the only thing you're supposed to do now is to subtract from 180 there, and then you prove that also this is what 7 to 1, 565, and then base angles. So what there is the thing now. I'm interested in what are you gonna do if the angles are the same. How are you gonna write it? How are you gonna conclude? Maybe let me say that.
Well, then it's good. Therefore, triangle ABC is a triangle because of two angles are equal.
No. You must use Euclidean.
No, you must use
Euclidean. The mathematical Euclidean. So what you're gonna say is this is what they say. It's angles equal. This is what they write. This is now coming, of course, from the grade 12 Euclidean. You are going to say equal angles equal sides.
Sides.
You understand? Equal angles equal sides, or equal angles equal opposite sides, because this angle will
I was
oppose
gonna
that
write a
this
long.
one, you know.
I was gonna write a long story that says the exact same thing.
Yeah, I understand, but they will still mark you. But please don't just say the angles are equal is an isosceles triangle. They want to find out the
Opposite
concept
angles
behind
equal,
the
yeah.
concept behind equal angles. Or you can say this, man, base angles of an you can actually state that statement. There is a statement which says an isosceles triangle. You can say base angles. The word key there is base now. Base angles are equal. You see, base angles are equal. Therefore, it is an isosceles triangle. Actually, I didn't also say much. Base angles are equal. Therefore, AB is equal to AC, which is an isosceles triangle. You understand? The key part there is AB. Or you mentioned another way. The way to prove also this, I think that's what they wanted. Look, they gave 5 marks, man. This is unfair because there's nothing to prove, which means in a way they expected students to go on distance proof. You see the distance to say we'll find distance AB and find distance AC.
Yeah, but they're the ones who gave a sloppy question, because
It's a
if a
sloppy
student
question,
can
man.
already
It's a
identify
sloppy
that
question,
the two
trust me.
angles are, yeah, if the angles are equal,
Yeah,
then
you know what? With N3 sometimes, not really N3, different exams. You know, sometimes examiners, man, they don't. I don't know. You know what I mean? I won't say much, but yeah, it happens. You know, where they ask a question and the answer is obvious. You know. So this is all they wanted you to follow that rule. I mean, 5 marks. This was supposed to be actually maximum 2 marks. This question. You know?
because at the end of the day, nonetheless, if you use the distance formula exactly as it is, it's still not
It's
5
still not
marks.
5 marks, man. You know. And look at what was unfair. They gave this one for gradient AC and AB. They gave it 4 marks. But now gradient, I mean distance, they give it 5 marks more now. Okay, it's fine. Now look at this one.
He was giving 3 marks.
Look at this one, man. Shall sketch the graph of I don't know why it was this one. Sorry, it's not there. I think when I was cutting this thing, it got left out. Sorry about this. But we'll do it anyway. It's graphs.
Yeah.
We'll do it during the time we do graphs. I'm interested in 5.2. Look at this. It says determine dy over dx of y is that. This is 5 marks. Leave your answer with positive exponents and insert form where applicable. I also say it's not worth 5 marks, but let's look at this question. What did you say?
Okay, so let me just write the question down. F of x is equal to 1 over 3.
No. It's the other one. It's the other one.
Oh, I'm writing one at the bottom.
Yeah, please determine dy over dx if y is equal to this one. That's this one.
Y is equal to open bracket square root x minus 4
Close the bracket.
square.
Yes.
Okay, so what do we have here? We've got ourselves. So I've got to simplify this.
Yes, you're gonna simplify this first.
So y, since it's squared, so when it's squared like this, what do I do? Should I open up this
Thank you.
bracket? Or
You have to. You have to,
this
man. Because remember I said we need to get it as simplified as possible before we can apply the rules. So what do we have? So which means it's twice that, right?
So this one here, yeah, it's twice this.
It's twice this.
So we're going to give us our this squared. So it's going to be the, what is this bracket again? It's bracket square root x squared, and then it's going to be minus 8 square root of x.
Okay, like this, squared
plus
minus 4 minus 8 square root of x plus 16. Yes, thank you. So y is equal to, because you're opening up, isn't you're opening up. Yeah, that was expansion. This and that.
Expanding, so that's going to give us with the x.
Okay, so that give us x, yes.
This is going to give us minus 8 x to the power of a half plus 16.
Thank you. So let's go dy over dx now.
So dy over dx.
So you see that's where we can apply it.
Yeah, so that gives us, we have to multiply it by the 1. So that will be x 1 minus 1. Then minus, we've got 8 multiplying by the half. And that will be x a half minus 1. Then that's just plus essentially 0. Then we've got 1 minus 1 it's going to be x to the power of 0, so that's just going to be 1.
Yes, thank you. That becomes
1
a 1.
minus 8 times a half is 4. A half minus 1, we've done this again, is 3 over 2.
No. Half minus that.
Half minus 1 is a
It's
half,
It's a half there.
1 over 2.
Yeah, let me see their question. They're saying leave your answer with positive exponents and insert form. So they need us to further this thing. So what
They wanted it in third form, so it's going to be 1. I can leave the 4 as it is.
Yes, thank you. Just leave the 4 because it's on top, you see. When it doesn't have an exponent, it's on top.
Yeah, so it'll be 1 minus 4 root x.
Root x, because that becomes x to the power half, which is root x. Perfect, you're right. You know, that's perfect. You know. And you were just asking something here. Let me look at this. Look, you asked me a question to say, can this thing, it can be done. Don't worry about this whole thing. This was the best to me. What was it? It was square root of what? X minus 4, right? Squared. There is calculus that allows you to do this. To say, you can do dy over dx here. I'm just working on this like here. dy over dx. First of all, what you do is consider what is inside. Differentiate, forget about the square. Differentiate what is inside. When you differentiate what is inside, remember this is x half. You agree with me? This is x half, right? So when you differentiate it, you drop there. You have got 1 over 2. Am I right? And then x, what do we have? 1 over 2 minus 1. Remember that. The inside. Then you put a bracket. Drop this 2. You're following the same. We have done the inside. Now the second one, you drop this 2. Right? When you drop the 2, it becomes 2. Then open bracket, write what is inside, which is x 1 over 2 minus 4, 2 minus 1.
Okay.
You see, I still subtract. I dropped it and subtract. Let's do that. Let's simplify this. What will it become?
So it's going to be 2.
This is
x.
On the part is 1 over 2.
Is that 4 or 1? No, on top here,
Okay, sorry about that. Oh, sorry. That's a 4. Sorry, minus 4. Yeah, that's a 4.
Okay.
Yes.
So we've got 1 over 2 x.
Negative half there.
Negative half.
Right.
Then we've got
that 2
times.
That is multiplying. So
that
we can actually
go all the way.
We can actually go and cancel this thing. You see that?
Yeah, 2 cancels that.
So let me just leave it out there. Are you with me? So that was just x, right?
So, yeah, this 2 will cancel that other 2, so those can go.
And bracket, I have got this x 1 over 2 minus 4. Am I right?
Yeah.
Am I right here?
Yeah, because 2 minus 1 remains as 2
minus 1. Am I right? And then how do we simplify this further?
So to simplify this one further, so
this time let's open it. Let's open the bracket.
Yeah, okay, because I was thinking that we're done, but we're still opening brackets. Yeah, so it's going to give us
x to the power negative 1 over 2. When you multiply,
plus
is
minus,
plus half. You see that?
Yeah, but now since it's got a negative, it's got a negative, it will subtract.
No, we are multiplying. Remember, it's negative half plus. Yeah, it will subtract.
Negative
half plus half. Yeah, right. Yes, it will subtract. And then after that, it's minus 4, right?
Minus 4.
X to the power what? Negative half. Am I right?
X to the power
negative half. So what is this?
Yeah.
This is 0. Am I right?
That's 0.
So that becomes x to the power 0 is what? It's 1.
This is 1.
Minus, let's convert this back. It's 4 over what?
Square
root x. You're allowed to do this, but yeah, you just need
that one's tricky.
Yeah, it's tricky. It needs you to be, but I'll say please go this route. It's
longer, but
it's safe. It's safe.
Easier,
you know what? Okay, you know what I can say? In case, let me just do this. In case, should they do this? In case. But that is under rare circumstances. In case, if they say to you, you are given y is equal to, for example, 1 plus x, let's say x4 to the power 10, and then they say differentiate this. Now you are forced to do the method I did. Do you see what I just did?
If you did what? Sorry, can you repeat it?
Let's say they say define dy over dx here. I'm saying in rare cases, if they say find dy over dx where the exponent is 10, so you can't expand this thing now. You understand? Then you are now forced to say, okay, I'll first do the inside, which is equal to, when you differentiate the inside, you drop the 4, then you say x 4 minus 1. You see that? Then you put a bracket, and then you drop further the 10, which is 10, and then you bracket 1 plus x to the power 4, 10 minus 1. But I'm saying in case, that is rare. I haven't seen that, but you can find it in the metric side, That is, yeah. But I haven't seen this question. I haven't seen it. All right. So
yeah, they're killing these matriculants.
yeah, you can get something like that just to see the part, So what I wanted then to do, no, this is not done. Look at this. That was fine. Let's look at this one now. Let's look at this one. Where was this? Let me reduce the size. Look at this. It says here, consider the following function. Are you with me?
Yeah.
Consider the following function, and then you're given f of x is that. Then it says make use of differentiation. That's why I put this question, because it's just a flow of dy over dx to determine the coordinates of the turning points of f of x. Now, what do you think here? Let's write this question again. Let's write f of x there. Let me bring it. We have got f of x. There it is.
Yeah, I think it's f of x plus h minus f of x over h.
No. That's not the one now. Look at this.
Is that not
That's not the one now. Let's write f of x.
Oh, rewriting this
I'm
question. I've rewritten
yes.
this question. Yeah.
1 over 2 x squared. Now, when they say to us here, it says consider the function. Make use of what?
Differentiation. Also, because here they didn't. What is it? They didn't put that limitation h goes to 0.
So we don't use that. No. Here they're talking about turning points. Now, what I want you to know is when you see that word turning point, every time you must know turning point is dy over dx. Whenever they say turning point, don't forget turning point is what? dy over dx. Now, let me give you a little bit of history here. When you've got a formula there, go to your formulas. Tell me there is a formula which says x is equal to minus b over 2a. I know you know this formula. Go to your formulas. What is it saying about this formula? Can you check your formulas?
Let me go to the formula sheet now.
X is equal to minus b over 2a.
This is a memo. I don't want the memo. Then we're going to differentiation. It's differentiation, yeah?
No, graphs. I think it's on graphs.
Oh,
graphs. It must be
logarithm, straight line.
Something there, man. I think it must be there.
No, they didn't give us that formula.
Where you find the quadratic formula?
Oh, there. Yes. Okay, yeah. It's x is equal to minus b over 2.
What did they call it? Line of symmetry. What did they say?
They didn't say anything. They just put under parabola.
Under parabola. Thank you. They put under parabola. But in the parabola, if you take it from n1, n2, this is your parabola, and that is the line of symmetry. That line in the center. That line of symmetry there. When you're out to find the line of symmetry, it is said to be this point x is equal to minus b over 2a. Are you with me? Then,
I'm with you.
Now, where did they get this? If I give you back, remember why they wrote this to your formula there? They said ax squared, right? Plus bx plus c. Now, what they did is, let's find dy over dx here. On this thing.
In this one here, dy over dx, so we'll drop the 2.
So it's 2ax
2 minus 1.
Which is x.
Yeah, and then plus b. And then drop the 1, so that can remain as it is x.
1 minus 1, which is 0. So this is b, right? Plus c is a number. C becomes 0. So now you have got this as final. Now I'm saying then at this point now, Sabelo, pay attention. At this point,
what we want is x.
You see, at this point we call this the turning point, TP. This dy over dx is equal to 0. Okay, then you take this guy, which is 2ax plus b is equal to what? 0. Take b to the other side. We have 2ax is equal to minus b. Divide by 2a. Divide by 2a. See where they took this formula from? There is your x is equal to there. There it is.
So it's differentiated.
Thank you. That formula is a differentiated formula. But when you're doing n1, n2, you must appreciate that it's a line of symmetry. They just give it to you. But you must know that it is a what? It is a differentiated formula. So when they come to this question, let's bring back to this question, and they say to you, you are given this question, and they like, you make use of differentiation, again, differentiation to determine the coordinates of the turning points. I'm telling you, the moment you hear this word TP, you must know I must use differentiation, meaning go there and say f prime x. After you get f prime x, just like I did here, you're going to equate it to 0 at turning point. You understand? So let's find f prime x here. What does it become?
So here we've got equals a third times 3
Yes.
x 3 minus 1 minus a half times 2
Minus 1 over
x
2.
2 minus 1, what does that leave me with? 1 over 3 times 3.
So this is x
So
what?
that's 1. That's x 3 x squared minus a half, that again will be this with 1. So that's x.
Like that, right?
2 minus 1 is 1. Yeah, that's x.
So that is this. Then you write this. This is the statement they are waiting. Then you say at turning point, f prime x is equal to 0. Always remember that. All right, because they told you here, they told you find the coordinates of the turning points. You see, so you must always know the derivative at turning point is always 0. But I will explain this when you go to graphs. Then from there, you take this guy here, which is your x squared minus x. You equate it to what? To 0. Then you solve for x. I think you know that. Factorize x there, which is x minus 1 equal to 0. Therefore, x is equal to what?
X is equal to positive 1. Or x is equal to 0.
There. But the question was find. The question was find what, make use of this to find the coordinates of the turning points. So you didn't find it. You find only the x coordinates. So you must go to the original f of x. You know x is 0. So here you put x is 0. So you can see when x is 0, y is 0. So the first coordinate is 0, 0. See that? Then the second coordinate, when x is what? 1. You put 1 also here. So you put your 1 here. You put your 1 here. So what will be the coordinates? If you can put 1 there on your calculator.
That will be f1. F1.
Yeah, f1.
Yeah, 1 cubed, it just remains as 1 the entire time.
Yes. So it will be 1, 3. 1, so it's 1 over 3 minus half. You're right.
Minus half, yeah.
So when x is 1, what is y?
Minus 1 over 2 equals negative 6.
See,
Negative 1 over 6.
That's it, man. You get it. You get that? So what I want to say, don't make this, it's 5 marks, but trust me, man, it's a given. It's just calculus. The only thing you have to do, take your normal, this thing flows, actually, it's even the same thing that we are doing here. 5.2. You are finding dy over dx. They are even giving you marks for even finding dy over dx here. And just equating it to 0. And then after equating to 0, solving for x. After solving for x, taking the x values, 2 of them, putting them into the